Welcome to day 2 of solving systems of equations using substitution. Today we're going to use the knowledge you gained yesterday on how to use substitution, and we're going to use the prior knowledge you have of distributive property and bring these two skill sets together. Here's our first example. Using our notes from yesterday on how to use substitution, our first step said, if needed, isolate one variable. In this case, the step 1 is completed since y is all by itself in this equation. So we're going to move on to step 2, which asked us to substitute the value of the variable into the other equation. Now what's different today than yesterday is there isn't just one single term or number for this variable of y. We have x plus 2, and so we have to make sure we take all of that information and substitute it in for y in this other equation. So we're going to go ahead and do that. And now, just like yesterday, we'll combine like terms if we can. And then we will use our knowledge of solving equations to get this variable of x all by itself. Once we do that, we've solved the equation, which was step 3 in your notes. We're going to take that information and substitute it back in to our original equation so that we can find the value of y. And again, our last step is we always write the solution as an ordered pair. Here's our next example. Step 1, I'm going to make sure one of our variables is isolated, and lucky us, once again, there is one variable isolated, so I'm going to go ahead to step 2, which is to actually substitute the values into the other equation. So I'm going to take the value of h and substitute it into this other equation. Now please notice on this other equation what's different in this example compared to the last example is we have a 3 here that's being multiplied by the value of h. So please be careful that when you are copying over and substituting in your variables that you do not drop any information from the equation. I see a subtraction sign and I want to make sure I don't make any mistakes with my sign, so I'm going to go ahead and add my opposite and take care of that right away. Now I'm going to go ahead and use my knowledge of distributive property and distribute out that 3 to the group. I'm going to combine my like terms, and then I'm going to use my knowledge of solving equations in order to get the value of g. Once that is solved, I've now done step number 3. So step number 4, I'm going to go back in and substitute what I solved for g into the equation. Add my opposite so that I now have my value of h. My final and 5th step is to make sure that I put my solution as an ordered pair. I don't have x and y this time, but if you remember from the video yesterday, you always place your solution in alphabetical order. G comes before h in the alphabet, so the value of 1 will come before the value of -5. There is my solution to this systems of equation. Here's our next example. One variable has already been isolated, so I'm going to go ahead and substitute that information into the other equation. Just like our previous example, I'm going to use the distributive property. Distribute out that 2. I'm going to combine like terms. Now in this situation I have a -4x plus a positive 4x. That's going to cancel out my x's. So I don't have any x's left. So on this side of the equation I am just left with 10. The other side of the equation I just have that 6. Now in math we know this is not a true sentence. 10 does not equal 6. The way they show that in math is to put a not sign through the equal sign. When you have your two sides of your equations and they don't equal each other and the variables have been canceled out, you don't have a solution. So in that case your answer that you will write down is no solution. Here's our final example. We have one variable that's already been isolated, so I'm going to go ahead and take that information and substitute it in. I'm going to use my knowledge of the distributive property I'm going to combine like terms. I have a positive 9f and a negative 9f. When I bring those together, they will cancel. So on the left side of the equation, I'm just left with negative 21. On the right side of the equation, I had negative 21. In this situation, when you have both sides of the equations equaling each other and your variables have canceled out, your answer is you actually have infinitely many solutions to this system. If we were graphing these equations, we'd have the lines line up perfectly, one right on top of the other, and that's why you have many solutions in this scenario.